Hey, how's it going? So for this module, we'll be covering the area of non-right triangles. So when it comes to finding the area of a non-right triangle, we'll utilize this formula here, which is going to be on your formula sheet as well. So it's 1/2 times A times B times sine C. Lowercase letters, remember, are side measurements. Uppercase letters are angle measurements. So if I'm looking at this figure here, A and B are specifically one of the adjacent sides to the known angle, and C is the included angle. So in order to find an area of a non-right triangle, you need two of the sides and you need that included angle. All right, so two of the sides and the included angle. So if I were to plug this into the formula to find an area of this triangle, 20 and 62 are my A and B. Ignore like this saying A and B and C as angles and stuff like that, because those letters could be anything. Just understand that A and B in this formula represent the sides that are adjacent to the known angle. So if you know this angle, those two sides that create that angle are your A and B. Your C is the included angle. So if these two are my adjacent sides, that means this is my included angle, which is 130 here. So then, no long as I have that, that's enough information that I can go ahead and find the area of said figure, and you'll get 474.948. So now let's look at an example like this. So I'm going to do this problem three different ways. So think about what I need in order to find the area of a non-right triangle. I need two sides and an included angle. I got three sides, but now I got to figure out which one of these angles I want to solve for so I can plug that in to find the actual area of the triangle. So then now let's start with C. Let's say we want to find angle C. And then so in order to find angle C, we have to use the law of cosines. We have three sides and we're looking for a missing angle. So when we use the law of cosines, we're looking for angle C, right? So that means 8 goes on the back end, all right? And then 14 and 19 are my adjacent sides here. Those are my A and B in regards to the law of cosines. So the 14 and 19 go there, 14, 19 go there, 8 goes here. And then once I find this answer, I got to do the inverse of it, and I get 22.075. So from there, I can plug in 22.075 as my angle, and then my two adjacent sides to the known angle now are 14 and 19. So 14, 19, the included angle is 22.075, and you should get 49.984. So this is what we got when we actually found angle C. So now let's say you looked at this problem and you didn't solve for angle C. Let's say you say, you know what, I'm going to solve for angle B, and I'm going to use 8 and 14 as my adjacent sides. I'm going to use those for my A and B as 8 and 14. Cool, you should get to the same exact answer. All right, so let's go ahead and use law of cosines again, but now the angle that we're looking for is B, which means on the back end of our equation here is going to be 19 because that's the side opposite of said angle. So our A and B here are 8 and 14. So I went ahead and plugged those in, and then 19 goes here. So then once I do that, I got to do the inverse of it, of course, because I got to get B by itself because I'm looking for this angle B, and I get 116.801. That's still enough information to find the area of the triangle. Our A and B are 8 and 14, and now our included angle is 116.801. And you should get the exact same answer. And you can kind of see where we're going now. So let's say we saw the same problem and we said, I want to solve for angle A, and then I'm going to use 8 and 19 as my A and B, which are the adjacent sides to the known angle, because it'll be known at that point after I find angle A. So if I want to find angle A, 8 and 19 are my A and B in regards to law of cosines. And then 14 will be on that back end where you subtract it. All right, it'll be the C. So then you see here, and then I do inverse cosine, and I get an answer of 41.124. So what that's telling me is angle A is 41.124. My A and B are 8 and 19. So when I use the area formula, I have 8, 19, and sine of 41.124, and I should get the exact same answer. So what I want you to notice here, it doesn't matter how you solve it, as long as you follow the exact process and your work is correct, your answer is going to end up being marked as correct as well. All right, but I want you to see these type of problems because they're not going to just say, hey, plug and chug, go find the area. They might give you a problem where you have to do something else in order to get the information to find the area. All right, so just be aware of that. Now here we use law of cosine. Sometimes you might be using the law of sines or the different law of cosines. All right, but let's go ahead and keep working so we can look at a couple more examples. So let's say we have an example like this and we want to find the area. Anytime you're given two angles of a triangle, just go ahead and find a third angle. So now we have three angles of a triangle and we have a side. All right, do we have all three sides? We do not. Do we have two sides with an included angle? Because that's really all we need for the area. We do not have that either. So what we're going to use is the law of sines. So now we have to use the law of sines to find one of these sides. It doesn't matter which one we find. And then at that point, we would have enough to be able to find the area. Because let's say I found this side first, right? We would have side, angle, side. We would have two sides and an included angle. Let's say I want to find this side. Cool. We still would have two sides and now an included angle would be 60. So it doesn't matter which one we do, you still would have enough, but you still, from here, we would need more. So let's go ahead and find, let's say side A. All right, so we want to find side A, we got to do law of sines. So we will use law of sines of 3.7 over 45, and we will set it equal to, if we're looking for A, we will put A over sine of 60. As you can see here, go ahead and cross multiply, divide by sine 45, and we will get our answer of 4.532. Now we have two sides and an included angle. So then we go ahead and plug that in to our formula, and we will get our final answer of the area being 8.099. Once again, we use sine 75 because that's the angle in between the two sides that are known. So let's say we look at this same problem, and you said, you know what, I'm gonna find this side first. That's fine. So now if we're looking for this side first, we're still going to use law of sines. But now when we use law of sines, it's going to be, what is it, 3.7 over sine 45. And then now it's going to be C over sine 75. As you can see here. Go ahead and cross multiply, divide by sine 45, and we would find our answer, which is 5.054. So that's this side here. So now we still have two sides, but now our included angle, instead of being 75, our included angle is 60. So now let's go ahead and plug it into our formula. 1/2 times A and B. Now our two adjacent sides to the known angle are 5.054 and 3.7, and our included angle is 60. And then we should get our exact same answer. Now, I know how you see this is 8.097. Because we are rounding these numbers here, it might be off just a little bit, but you would get marked 100% correct as long as your work and your process match your final result. Because as long as you're rounding, your answers may or may not be a little off at the end. So I do want you to write both, and they both are correct. So now let's look at our last example here. Let's say triangle ABC. Let's say side AB is 10, side AC is 13, and the area of the triangle is 62. Find the two possible angles of A. All right, so let's draw it first. So this is what we got. We got two sides and we're looking for this angle here. But we do know that the area is 62. So first thing I want you to do is write down everything that you know. What do you know? The area is 62. And we know that the two sides that are adjacent to the angle are 10 and 13. So now when we look at it and we write it down, it looks a lot easier. We got one variable x. We got to solve for it. Okay, how do you get rid of a denominator? Multiply by it. Multiply 2 to both sides and you get that 124. And then we took 10 times 13 and got 130. Now we got to isolate the sine x. So we divide by 130 and we get this. And then now in order to get x by itself, we got to do the inverse sine. But remember, when you do inverse sine, it's going to be two possible answers. So while I'll do inverse sine here, and I'll get 72.525, that's a possible x value for this angle. But because doing inverse sine is more than one possibility, you got to take 180 minus that, and you would get 107.475. So these two are our two possible angles given the information above. And just like that, it's time to practice. Questions, concerns, feel free to let me know.